Good afternoon, ladies and gentlemen. You're tuning in to the ARCHIDEX Fast Forward webinar series, brought to you by ARCHIDEX. I'm Joyce, I'm your host for this session. I know it's been a busy week, and at this hour, I want to congratulate you for being here, and we believe that there's no better time than now to share on crucial questions to ask for metal cladding. Well, speaking of a busy week, I would like to ask all of you a quick yes or no questions. So if your answer is yes, please tap Y in the comments and type N if your answer is no. All right, how many of you present here today have already started traveling, whether it's back to your hometown, a short getaway, or just a day trip? Type Y for yes if you have already started traveling, and N for no if you have not. Right, just in case you have missed it, the question here is, have you started traveling already, whether it's back to your hometown, a short getaway, or just a day trip? Interact with me using the comment section. Type Y for yes and N for no. All right, I see that, we have some, and I believe many of you have actually missed traveling. For me, that's top of my list. I want to travel so badly. All right, honestly, that's the first thing I'm going to do. If I can travel, I will be going out of this country. All right, for those who are planning to travel, please do remember to stay safe. All right. Okay, I do have some other comments coming in. There are some of you who has already started traveling. All right, thank you so much for all your response. And it's really refreshing to meet new people in this platform. Okay, back to today's session. ARCHIDEX Fast Forward is a webinar series focused on a holistic perspective from the industry. Each session brings together collaborations from the industry with renowned architecture and building professionals, sharing their experiences from various perspectives, including industry, business, education, to address current key issues and topics. Please note that this session is CPD applicable. To claim your CPD points, please follow the instructions in the comment section. Thank you once again for taking your time today to join us. All right, back to today's session. Ladies and gentlemen, when you stay to the end of this webinar session, you will learn that if you are designing a large warehouse, metal cladding would be a common choice of material. But when it comes to cladding longevity, it does not only rely on the material. Selection of cladding accessories serve the same importance. So in this session, the speaker will be using some key observation and learnings from his experience in site inspections to add value to this session by sharing more practical approach of material selection, both for the metal cladding as well as the cladding accessories. So if you have any questions you would like to direct to our speaker, please feel free to type in your questions in the comments, and we will attend to them at the end of this session. Our topic for today's webinar is crucial questions to ask for metal cladding, and we are honored to have Mr. Rocky Shit, Technical Marketing Engineer from NS BlueScope Malaysia Sdn Bhd. He is responsible for providing trainings and product presentation of NS BlueScope's coated steel products to developers, architects, contractors, and other relevant parties covering Malaysia, Singapore, Brunei, and South Africa regions. Well, without further ado, ladies and gentlemen, let's bring in Mr. Rocky on screen with me. Hi, Mr. Rocky.
Hi, Joyce.
Hello, how are you today?
I'm good.
All right. Over to you, Mr. Rocky.
All right, cool. Thanks, Joyce. And if you ask me the questions whether I, miss traveling outside of the state, my answer is yes, and I will be doing that very soon for work reason. So anyway, back to the topic of the day. So what crucial questions to ask for metal cladding for large warehouses? So when we were preparing for this topic, we had to think about, the type of buildings that are popping out here and there in Malaysia. And when we thought of that, mostly, we have a lot of, warehouses popping up, mainly fueled by a lot of reasons, partially also due to the e-commerce trend that is booming right now. And of course, why large warehouses is because when we are designing large warehouses, the surface areas of the roof is tend to be large, right? And of course, the cost for you to to shelter the warehouse should be quite huge amount as well. And if let's say you look at something like as shown in the slide here, is you have a long length roof, and if there is any leakages or any sorts of misinstallation or misuse of materials that occurs on this long length roof, then the cost of replacement or cost of repairment tend to be huge. So it is very, very important for you to take a lot of things into account before you make a decision, right? And a calculated decision rather. And of course, that requires both part, which is in a sense oversimplification of what goes on into designing or even installing a building. But to put it simple, I would like to just segregate it into two parts, right? So the first part is design and second part execution. But today, the crucial questions you should ask is more towards designing, because in the designing stage is where you can decide early on what kind of material to use, what kind of specs should you choose for different for different types of warehouses. And today I'll be sharing large warehouses that spans across those warehouses that are for, say, e-commerce, which are largely activities are benign, all the way to warehouses that are much more corrosive in nature. And both you can take this into consideration and ask crucial questions that needs to be asked during the designing stage. So ultimately, what we want to do is actually to prevent corrosion, because the pictures here shows roof started corroding, or even prevent corrosion also would mean that it would lead to leakages, right? Roof leakage, which is not a fun thing, because you often need to trace where are the leakages, right? And with a huge roof, imagine the work that you need to do, and then the replacement that you need to go through, right? And of course, not to discount the potential effect of the roofing sheets getting detached because of such losing of fasteners or corrosion of fasteners, right? And of course, ultimately, we want to prevent uncertainty, right? So these are just questions that you need to ask in the early stage, so that when you go into doing documentation, specification, it's much more clearer for you to have that information in hand to make an informed decision, right? So whether it be planning for the worst type of environment, like I mentioned earlier, corrosive substances, or warehouses that stores corrosive substances. Yeah. So over here, I'll be attempting to break down certain parts, starting, of course, from the cladding itself. Of course, much more overlooked components like fasteners, flashings, and also the lightning conductors, right? So these are basic components where you employ basic materials that often has to rely on certain working principle to work, for it to work hand in hand, right, as a roof system as a whole for large warehouses, right? So the principles of how different materials work together, right? We'll be using so-called the galvanic reaction, the principle of galvanic reaction as discussion point. So in order for you to understand or to benefit from this session, I think it's wise that we revisit the high school science basics about galvanic reaction, so that you can recall what you learned back then, and also what you can learn from today's session, right? So what galvanic reaction means is that you pair up two metals together, and then you connect it electrically, right? Whether it be by a wire or by actually directly contacting each other. And of course, the third one is a medium where it can be submerged in water, right? Or it can be rainwater, so which is nature, right? So that is what we call electrolyte. And by pairing two metals together, for example, aluminum or zinc with steel, you create a system where we call galvanic series, right? Or galvanized steel, right? And this has to do with so-called the galvanic series chart, right? You search on Google, search online, and you can get this information easily. And most often, what you can see is that under the galvanic series, you have all sorts of metals, all the way from the most anodic one all the way to the most cathodic one, meaning which one is much more reactive out of the chart, right? The one that is skewed towards the cathodic one means that it is less active when it's paired with a more anodic metal, right? So let's just use an example. Just now I mentioned galvanized steel, right? So it employs aluminum zinc or a zinc with steel. So in this case, the aluminum and zinc are much more, are more active than steel. Hence, it will actually be protecting steel rather than the other way around. All right. And here you can see all sorts of other metals like copper, brass, stainless steel even. And these type of metal are relatively less active than steel. Okay. So in that sense, these metals that are less active, like copper, brass, it will actually cause steel to corrode rather than copper or brass. All right. And another thing that you need to know is that the further it is two metals, then the faster the reaction. Okay. Of course, today we are just simplifying a lot of this principle because technically there are measurements to measure how fast the reaction can be, right, in different environment. Okay. And so for example, if let's say you have graphite on one end and you pair it with aluminum and then you contact them together, the reaction of this aluminum will be much, much faster if let's say it is paired with graphite compared to if it's paired up with steel. Okay, so that is another things that you need to know. And the third thing is, if you increase the more active metal, then the protection will be much more faster. But if let's say you do the other way around, where you increase the cathodic metal, right, then the protection will be lesser, right? That means you will see rust much faster. And again, just now I mentioned, once you see rust or you see corrosion, that is not what we want for especially large warehouses, right? So let's get to the different components that I mentioned earlier. All right. Again, bear in mind of this galvanic series principle, which you can always search online to refresh your memory. Okay. So the first one is fastener. Okay, fastener is definitely used to lock down all the cladding material, right? And is most often, referred to as fasteners. I mean, laymen can call them screws. People who are not familiar. So, but we call them fastener in our industry. So, there are many types of fasteners, right? And the one most often used are for metal cladding is what they call self-drilling fasteners, meaning you don't need to make a hole. You just use this fastener and then it will drill through, right, without making any holes, and that tightens it onto the batten, the structure per se, and lock it down, right? But throughout the years when I go on site and do inspections, right? What caused the failure? What caused the roof leakages? The site of non-performing fasteners, like what you can see on the picture, often happens, right? And this can be due to the fasteners are not suitable for the environment, right? That's why it ruts. It starts rusting. Okay, that means the environment is just too corrosive for this fastener to last long. Okay, or the other way around, the fasteners are just not suited. I mean, it's not, it's not a quality fastener. Okay, so what this will impact is the fastener itself will start rusting, right? And it will actually start spreading around where the contact area is, right? So remember just now we mentioned about the galvanic series where the more metals, I mean the anodic, the more catalytic metals there are, then the active metals will start reacting. So in this case, the coating around the roof actually starts reacting because there is actually rusted fastener. All right, so those white color dust are due to the reaction. And of course, it will lead to, initially will lead to ugly stains, right? So it's very easy to spot, especially if let's say your warehouse is located in a corrosive environment, in a corrosive location, right? Like near the sea, or it itself is a corrosive entity, right? So coming back to the fastener type, there are actually many different types of fastener protection system, which are not normally seen easily by naked eye. But a lot of manufacturers would definitely have their own marking on the crown of the fastener to make sure that they differentiate between the one with, like class 3 fasteners, which are, better than, class 2 or class 1 fastener, right? Or even class 4 fastener, which are meant for a much more severe environment durability, right? So in this case, we normally would recommend, if let's say the fasteners are exposed on the external, okay, we would go for class 3 fastener minimum. And if let's say it's near sea or in an industrial area, then you go for class 4 fasteners. Okay, so that is our normal recommendation. And because we know that the cladding itself is able to last for extremely long, we're talking about 10, 20, even 30 years sometimes. So the fasteners naturally needs to be that long lasting as well, unless it is known early on during design stage that the fasteners are not able to last so long. So you need to budget in. You need to make sure you make that decision consciously, so that you can have an honest conversation with the investor to tell them, okay, these are the things that we know cannot last long. So how do we go about it, right? Of course, later on I'll share some of the approach that we have seen in the market that are common and is commonly practiced. All right. So what constitute class 3 or class 4 fasteners, right? So those are terms that are used, to quantify, whether the fasteners itself can perform in a certain environment in so long and so forth years. And of course, there are standards that governs it, right? So that you don't get what you see on the screen, right? These 3 different fasteners are taken on the same roof, for your info, right? On the same roof, and they will claim to be class 3 fasteners, when in fact the quality of it, it seems like most the top 2 doesn't seem to perform up to the standard, right? So it is meant to assure that, when you ask the questions to supplier whether I get class 3 fastener, is meant to secure your assurance, right? Give you an assurance that is a class 3 fastener, so that you can protect yourself on the long term. So that is a question that you need to ask for fastener. And of course, there are also cases where you have done the design, people install it, and then somehow the workers are not knowledgeable, and when they see that there is some defect on site, they go to the hardware shop and buy something that can just lock it down and call it a day, right? Without thinking long term. So there are fasteners that are not suitable, right? And as soon as you install it, it straight away rusts, even before hand over the project. We have seen such cases. I mean, it's really common, because the workers are less knowledgeable, put it that way, right? So it's either we tell them, or rather we make sure that the people who have a better knowledge be aware of it and make a warning, put a warning to it. Because as soon as you put a puncture to the roof, then there's no going back already. Like for this case, right, if you just remove the rusted, this I would call a normal screw that is not suitable to be used, then there's a puncture already. So how are you going to address it, right, in a more elegant way? There's no way of putting it very elegantly. There's a hole, okay? So, and we have also seen attempts where people just cover up the fasteners by painting over, and it doesn't work on the long term, because we have seen such cases before where, you know, you can see on the picture, fasteners that are rusted, then you just paint over it, then it will still rust from underneath, and eventually it will actually lead to another catastrophic failure as well. So what we recommend is make sure that you put it as an upfront requirement, class 3 and class 4 fasteners, or class 4 fasteners, and make sure that, you know, people don't just simply buy any types of fasteners to be used and just cover up their tracks using all these kind of painting, right, to cover up you know, the rust. It doesn't work on the long term. And again, on a large warehouse, it's even worse, because when it happens years later, then it'll be just too late. Of course, there's also another scenario where people ask, how about since you say, okay, class 3, class 4 fasteners, right, you need to assure, they give you the assurance of the fastener do not rust. How about if, let's say, I use stainless steel fastener, right? Because stainless steel, right, it doesn't stain, it doesn't rust. So again, going back to the 𝐿AM series, stainless steel fastener, when it pair up with carbon steel, remember the positioning. The one that is positioned in a more cathodic tend to not react, or tend to induce the one in the more anodic part relatively to rust, as what you can see from here. Right here, you don't see the stainless steel fastener rusting, but the material, which is steel, or even sometimes aluminum cladding, it will start rusting, okay, because of this galvanic reaction. So don't think it will be exempted, okay? So it will cause what we call a ring corrosion effect, where on the long term, the corrosion will start around the fastener, around where the contact point is. So when I say contact point, I mean electrical contact point. Remember just now I mentioned in order for you to have a galvanic series, there are actually three elements, three things you need to know. The two different types of metal, or more than two different types of metal. Then you need to have an electrolyte, which is rainwater. Then you need to have electrical connection, whether it be, you know, a wire connecting them that's conductive, or you have them direct contact. So in this experiment that we did, it was actually a direct contact. Yeah. After you drill through the fasteners through the material, then there's contact already. So of course, we have seen throughout the years, you know, there are innovative solutions to it, and ingenious solutions, I would say, where stainless steel fasteners supplier, they actually introduce a sleeve, something like what you can see on the screen, right? It is not common, right, in our region, but we have seen it in places like South Africa and so on. So it's meant to give an isolation, so that when the fasteners drill through the cladding, it doesn't create any electrical contact between the fastener, stainless steel fastener, and the cladding, right? So from there, it's reduces, or, you know, eliminate entirely the risk, right? So this is how it looks like after you drill through, and then you can see the highlighted part is actually the outer sleeve, right? That is non-conductive. Okay, by doing so, yes, then stainless steel is suitable, but again, make sure there's no direct electrical contact to it, right? So of course, there are other solutions which occurs at the profile selection site. So when you are designing for your warehouses, so I'm sure there are different types of profiles that are offered in the market, right? Different range of profiles, and for people who might not be familiar, what do you need so many profile for, right? So there are actually a lot of factors, in fact. Factors such as rain carrying capacity, how long it can span, what is the support strength, whether you want it to be installed with solar panels, the availability of a lot of things, right? So fasteners, it can be exposed, but it can also not be exposed for cladding systems where for there are profiles where fasteners will be locked with underneath the profile, so-called the roofing sheets, and then the roofing sheet just clip on it, what we call clip locking system or conceal fix system, right? So you can choose those kind of profile which are very common nowadays, right? And that would eventually eliminate what we call fasteners weathering from the external. But I'll get into if let's say it is a corrosive environment within, what are the things that you should take note of and what is the consequence, right? So let's get on to the second point, flashing and capping. Okay, so flashing and capping is very straightforward. It's used throughout the joineries of the buildings, or where you have where you have bending areas or sharp turning areas, right? As what you can see from here, right? There are a lot of different terms to what is used. Ridge capping, there's flashing and patch capping, a lot of things, a lot of terms, right? So as I understood it from the market, it might be broken up into different parts, right, during the construct stage. Okay, so meaning the flashings are packaged in one contract and be tendered separately with the cladding. So this created an environment where there could be two different materials used for the same building, where in fact the flashing and capping can be using the same roofing material to be bent into flashing and capping. All right. So traditionally, you encounter something like this, right, where the flashing and capping is less emphasized, put it that way, in terms of requirements, because people look at large surfaces, right? So the large surface of the roof tend to be prioritized. But let me just give you a reminder that any holes, any weak points, the whole roof is only as leak-proof as the weakest part of the building. So the first part, we talk about fasteners, right? The second part, flashing and capping. So those are the common small areas that could potentially cause the headache. So come back to flashing and capping. Normally what happens is that if let's say, those are what we've seen. It will actually, the flashing and cappings that we have seen so far, some are using inferior material. So what happened is that the material on the flashing, of the flashing would start rusting, and there will be stains coming off the rusted, capping or flashing, like what you can see from this picture. So we call them rusting because the rust will actually start spreading adjacent to where the water brings it onto. So these are commonly known as iron oxide, right? So for people who prioritize on looks, it tends to be ugly and very hard to remove, right? But on the long term, what happened is that, this is a close-up of the flashing with the roofing sheets. So on the long term, what will happen is that the steel on the flashing will start rusting. And remember, I mentioned in the galvanic protection, if let's say you have more of the steel compared to the protection system, then it tends to wear faster, right? So this is where it comes in. Imagine a flashing point, yeah, flashing or capping with the roofing sheets. So if let's say the flashing or capping starts rusting, the rust itself will start inducing faster reaction of the adjacent coating, right? And over time, the rust will, be affecting the performance of the adjacent components, right? Something like this, right? In a short span of maybe 5-10 years, depending on the environment. right? So the most straightforward, and this is one of the easiest solution or questions that you can ask is whether the flashing and capping can be made of the same material. Okay, so most often the answer is yes, right? Flashing and capping, because there are already people who are doing it. It's just a matter of asking and specifying it in your documents and put an emphasis onto the flashing and capping, right? So use the same material for flashing and capping as it is for the roofing. So you get a much more consistent long-term performance, right? Like what you can see from this picture. Right, so that's an easy question to ask. So moving on to the third point of lightning conductor. Okay, so lightning conductor, as I have seen throughout different region or different part of the world, is much more often asked in Malaysia, right? The reason why is because Malaysia is, I mean, one of the highest frequency of lightning strikes in the world, right? Put it in place in the ranking, it will be third highest lightning strikes frequency, right? Based on the source that I quoted down there. Right. So having said that, most building, if not all, would have some level of lightning conductors in place, or there will be consideration on how likely it is for the building to get struck by lightning. Okay, different part of the world, it will vary very differently. Okay, so normally for architects, normally you don't care about this. Okay, normally engineers will care more about this part, right? But having a bit of knowledge about this will equip you with some preliminary information to even start with a discussion, because there is a certain disconnect and also miscommunication, or rather lack of communication when it comes to lightning conductor. All right, so again, this lightning conductor forms a big part of an external lightning protection system, or LPS in general, we call it. All right, so of course there are various different types of components to be used, right? So all the way up to the highest point of the, or apex of the building, is where you have all these spikes to channel the lightning to the ground, right? I mean, that's what they are eventually going for anyway. So one of the most common material is copper as a lightning conductor material, right? We all know, even with our phones, our cables, everything, it can be made out of copper. Of course, second best to gold lah, but gold is just too expensive. But gold is one of the best conductors in the world as well. So copper, right? Copper is really good at conducting electricity. But coming back to the point of galvanic series, as I mentioned, the further it is, then the reaction will be much faster for the one that is at the more anodic or reactive side. So in this case, if you look at the diagram here, it will appear that copper is much more further compared to stainless steel. I mean, when it comes to distance to steel or aluminum or zinc. So when you pair them up together, what you have is a galvanic reaction mainly for steel and aluminum or zinc. And on the long term, this is what will happen. So copper will will cause the steel to corrode. Okay, and the corrosion will be much faster. Okay, if you have a contact. And most often people will say, oh, how about if I raise it up, right? So if you raise it up, there are chances that the reaction will be slower, but we do not deny that on long term, there'll be certain level of reaction. I mean, this is very, very clear. I mean, we cannot quantify how fast is fast. Again, it requires a clear understanding of the environment and also some quantitative understanding. But the end result is that we know there will be certain galvanic reaction, be it direct contact or raise it up. Okay, so we always raise it up to investors, but we do see that sometimes when we raise it up to, say, for example, engineers tend to prioritize on the lightning protection system, which makes it fair, right? But at the same time, we also have to look at the long-term feasibility, the long-term protection of the cladding. So if, let's say, in the long run of roof, then in the middle you have this rust, don't think for a second that you will just replace that strip. You will just replace everything because the whole strip is being corroded. So that is where it comes in to be very costly, or rather the solution would not be elegant. That's why it's very crucial for you to ask the questions early on during the design stage. What type of lightning conductor are we using? Is it copper or is it anything else? Right. So the severe case will cause the steel to be corroded until there's any types of leakages or perforations. Right. So again, imagine you have to really replace one whole strips of roof, or rather, if let's say it runs across the warehouse, then the whole warehouse roof, because of the choice of material for lightning arrestor or conductor, right? So these are some of the photos that we have captured, and what you can see here is quite lucky because the warehouse itself is situated in an industrial area, and the reaction sits in after only 2 years, if I recall correctly, this photo itself. And it luckily sits at the very end of it. But bear in mind, when there's lightning conductor, it normally runs along the perimeter of the roof, right? So potentially it covers a big area. Of course, we would not, raise this up as a problem if, let's say, we don't have anything good to suggest, right? So of course, one of it is you can do an isolation, which we have heard before from engineers that they do not prefer. They prefer copper, or so-called the conductor, to be exposed to so-called the external weather, so that there's no limiting point for it to be exposed to lightning and channel it down to the ground. So we ask and also search around the standards, any types of other practices, and we found aluminum tape, right? So instead of using copper tape, why not explore the options of aluminum tape? Okay, and aluminum tape, for a trivial fact, is that it is 39% less conductive than copper, meaning it's less conductive electrically than copper. Okay, and when consider other facts, like in the galvanic series, it is less reactive. I mean, it's more reactive than the steel, so it will not cause the steel to rust, and then the reaction will be actually quite slow, because we have seen such cases, right? And the way to go about it is that there are standards that recommends aluminum as a type of lightning conductor, and you can refer to the standards as shown here, EN 62305-3. Okay, so you can use it, and under the standards, it also recommends, okay, what is the minimum cross-sectional area for you to use this aluminum as opposed to copper as a lightning conductor. And those are the specifics that are stated in this standard. And not just that, it's also specified in some of the government agencies' specification documents, like JKR's standard documents as well. So in the long run, what we are trying to say is aluminum would not accelerate the corrosion of your steel, right? And this photo itself shows that aluminum will not corrode. steel. Right? Of course, we are lacking a lot of these studies because there are not a lot of people using it yet, but we have seen cases where copper definitely, and as a fact, based on the Galvanic series, that it will actually corrode steel. It's just a matter of time. Okay, so that is a crucial question you need to ask for lightning conductor. What type of material it is. And moving on to the last point, which is about treatment of unwashed areas. And what we mean by unwashed areas and how to treat it, right? So as you can see from this picture, unwashed areas are covered by where there is shadows, right? And of course, why is unwashed is because when you cover it, you shield it from natural rainwater. And the part where it is naturally washed by rain is considered the washed area. And the part that is naturally not washed by rain, it'll be considered unwashed area. Okay. And just like I mentioned, or like fasteners, which has a certain part of it which are drilled through to the roofing sheet, and the bottom of it is called unwashed area. It's because for unwashed area, right, it is quite dangerous on the long term. Okay, sorry, let me just get through the slides. Okay, so these are other examples of unwashed areas. Right, so this one is unintentional, but this is actually a chalet. I think it's a chalet or a power station near the beach, right? And it was unintentional because the ceiling fell off. But again, this is the unwashed area, right? It's exposed to sea breeze and whatnot. So when you consider unwashed area, the impact of it, we have to consider two things: the external environment and the internal environment. It's because we designed the building to be working harmoniously, not just by itself, but with the surrounding environment. And we have seen a lot of cases where it's not just your building design that is, that is good, but it has to also work well with the environment. Environments such as places like near the coastal region where there is actually a lot of what we call salt-laden air. Salt-laden air means when there is a strong sea breeze, wind that carries salt particles from the sea. The particles are invisible by naked eye, right? But you will eventually see it accumulating at certain part of the world, certain part of the surfaces. And spoiler alert, is on the unwashed areas. Okay, so these are some of the situations, or even industrials, right, where you see chimneys, coming up from nearby factories. I mean, and all these emissions that you are not normally, you cannot see from naked eye. Those particulates tend to distribute within a certain radius of the building, right? And eventually, you get all these, dotted. I mean, these are illustrations, but what you can see on the surface is, those dirt, right, or even dusts. So these are industrial dusts that settles on the unwashed areas, whether it be underside the roofing sheets or where there is shades. Okay, and why should we pay attention to all these unwashed areas? Is because on the long term, the unwashed area will accumulate all these contaminants. I'll call them contaminants, like salt or industrial settlements, right? Industrial particulate settlements. And potentially those areas will be susceptible to be attacked by all those settlements. And on the long term, you create all this unwashed area corrosion. So this is one example where it's actually situated next to a coastline. And you can see on the long term, there's a part of the roof, a part of the wall cladding that is corroded badly compared to the part that when rain comes, gets splashed on, which is at the lower end of the roof. You don't see any much of corrosion down here, but rather up here, yes, there is sign of corrosion. So there's a difference between unwashed area and washed area. And most often, we see it happening much more faster if, let's say, the building within the building stores corrosive substances. Just now I mentioned, right, warehouses, it could be non-corrosive like e-commerce type, and also there could be corrosive type like fertilizer factories, fertilizer warehouses, salt warehouses, and of course many more types of corrosive activities underneath, right? So it will create a lot of airbox. And just like I mentioned, right, fastener. So there is the unwashed part of it, where if let's say it's exposed to all these settlements, then eventually it will get corroded by all this corrosive stuff, and eventually it will get detached, right? As just now I mentioned the photo earlier. So those are the risks that we want to eliminate, right? So again, without any good solution or without any viable ones or successful ones, we wouldn't actually raise it up here. So to eliminate unwashed areas, there are actually straightforward questions that you can ask, right? When you're designing a large warehouse, you need to think about, okay, what kind of activities are within the building, right? Also, so we always ask this question as you know, that is our concern most of the time. Okay, so what you need to do is you can add, put in an additional budget, add in what we call a vapor barrier. Vapor barrier can be a foil material that is non-reactive. Okay, so by doing so, you create a shield where the non-reactive vapor barrier can act as a system to protect whatever settlements is underneath it. By doing so, you exponentially extend the lifespan of the whole system or the cladding system as a whole, right? And much more specific, it will be much better if, let's say, is a corrosive warehouse, right? A vapor barrier looks like this, and even a ceiling can do as well. Okay, so those are things that you can do to shield away the unwashed area from being exposed, right? The ceiling itself, typically they use a fiber cement board, then it will solve the issue, right? And of course, if let's say even the ceiling or even the roof itself is exposed, and then there's no budget to put in for this kind of system, or it's already been implemented, well, there is also a much more active solution where you need to do wash down, right, on a maybe by on an annual basis, or maybe every 6 months, right, depending on the environment. Okay, so those are solutions that are viable, right? But again, it comes down to asking the questions to begin with. So in order for you to achieve such design, I think is only right for you to ask the right questions, to know that, you know, these are the things that are important for this kind of building, large warehouses, because the consequence of not asking those questions will come back and bite you and be haunting you for many years to come. So to summarize, okay, I have presented 4 points, and each point has their own crucial questions to ask, right? Of course, I am trying to make some recommendations here, right? Fasteners, try to use at least a class 3 fastener, right, for external cladding application. Of course, you can totally eliminate it, as I mentioned earlier, by using some kind of concealed cladding, right, that fasteners are not exposed externally. Okay, flashing and capping. So encourage to use the same material as cladding, right? And you can always ask the questions whether it be possible. And we know it is possible. It's just a matter of you asking those suppliers. Okay, lightning conductors. Okay, so if let's say the system, the warehouse itself is designed with some lightning protection system, make sure you ask the question, what is the material of the lightning conductor? Because it will eventually cause damage to the cladding, to the architecture part, if let's say it doesn't have that compatibility in terms of material. So we recommend using aluminum instead of copper, simply because of the galvanic series. Right, and also treatment of the unwashed area. Of course, if possible, we would recommend eliminating it. Okay, again, depending on the environment. If let's say your environment is near sea, within 5 or 1 km from those sea breeze, or even within an industrial area, then try to eliminate it, right? And otherwise, you just have to go with the active solution of washing it down, right, on a frequency that is viable. All right, so with that, I would like to conclude my session today. And of course, if you like the sharing that I've delivered today, feel free to scan the QR code and give us a feedback so that we can improve upon what we are sharing today. And of course, you can always contact us via all the different platforms, and also go to our booth, during the ARCHIDEX time. And with that, I would like to pass back the floor to Joyce. Joyce?
Hello. All right, thank you so much, Rocky. That was an insightful sharing. Ladies and gentlemen, let us know your thoughts on this webinar. Click on the link to participate in the quick survey. All right, if you have any questions that you'd like to direct to the speaker, please feel free to type in your question in the comment section. All right, let's move on to our Q&A now. I see that we have a few questions from the audience. Okay, Rocky, we have a question here. Out of your experience, which of these issues is the most commonly seen? Rocky, over to you.
Yeah, thanks, Joyce. I think when it comes to commonly seen question, commonly seen issue out of these four, right? I would say the lightning conductor tends to be one of those issues that are most often overlooked and also prioritized by different parties. And I say this is because we know that lightning protection system is not a scope that architect is taking on, right? Because you require some engineering calculations and it requires some engineering work, put it that way. And we have encountered before where lightning protection system tend to be, a gray area, right? And engineers definitely want copper. I can tell you this because it is the incumbent material to be used as a lightning conductor. But I think we ought to ask the questions, whether it really is used, and if so, what are the consequences that we can expect? And we have to be realistic about it, and we have to be honest with the investor, so that they don't get misled eventually, that, okay, you are just offering the warranty, and so that if, let's say, the roof leak, then I can come back to you. There are actually scoops for terms of warranty where, sometimes it doesn't contain things that we don't do, right? Simply put, we don't assure that, the copper is going to work well with our material. So in a way, we have to think of, from the aspect, and I know that, there could be sometimes, people asking, okay, how about new innovation? Is there any new innovation? My answer normally to that is yes, but we have to always start by asking the questions first. Without asking the questions, then there would never be a good discussion to be had. So yeah, I think the lightning conductor is one of those that we have seen very, very frequently. Yeah.
Okay, so I guess the lightning part is the most commonly common issues in this problem. Okay. Moving on, I have a question from Mr. Joaquin Lee. Is there any isolation requirement between lightning conductor tapes from surface of the roof? Example, if the lightning conductor allowed to sit directly on the metal roofing is aluminium, or is there a guideline to have a minimum spacing between these two elements? You got the question?
Yeah. Hi, Joe.
Okay.
Familiar audience, thanks for supporting. When it comes to spacing, right, I don't think there is any guideline per se on what's the minimum spacing to be had. because we know that when I think what you're trying to say is that is when you raise up the lightning conductor away from the roofing sheets, how far is it that it needs to be so that it minimizes the reaction. So we have not had any research done, to be honest, on this part. How like as the distance goes, what is the effect it has on the material. But what we know is that if you raise up, even if there is no electrical contact, there will be still some kind of what we call electrolytes, which is the rainwater. And the rainwater, if let's say it is an acid rain, then yeah, so be it. The reaction will start faster than usual if let's say it is in a normal environment, right? So yeah, so I would say, sorry to disappoint, but no, we don't have such guideline. And when it comes to isolation requirements between lightning conductor tape from the surface of the roof, yeah, I mean, I think we need to start asking the crucial questions, whether it be allowed, whether engineers be open to it. And if they say they have a technical justification that says that we cannot isolate the conductor tape along, then yeah, then we can't change that. Yeah, but what I know when I see those lightning protection systems in place, right? There's actually those pins that raise up, right? It's mainly that the lightning will strike at the pin rather than the tape that is running along the roof. So I cannot really understand why not the isolation be done along the roof. So yeah, so those are the questions that definitely we need to take it offline and have more productive discussion. Yep.
Okay.
So
all right,
Joe, I hope that answered your question, or give you what I think.
If you want to know more about it and to discuss more, please do contact NS BlueScope, Joachim.
Yeah.
All right. Okay, moving on. We have a question which is sounds like this. How do you know the fastener is class 3 or class 4? How do you tell?
Yeah. Well, class 3 or class 4 fasteners, like I said, is very hard sometimes for laymen to actually know, unless you know the brand or the supplier of the fastener, right? Normally, on the fastener, there's a crown, right? There's a head, so-called head. We normally call them crown, and normally different manufacturer will have their own unique embossment onto the crown. And with that embossment, they will also have a numbering system. So, for example, if let's say I'm producing a fastener, I will have a R3 or R4, something like that. So, naturally, you can imply, R3 means class 3 or R4 means class 4. But again, don't take my word for it, because each manufacturer would use different embossment. Use different embossment system. And but what you can ask though is, how if let's say that is the supplier that is supplying a fastener, just make sure that you get an assurance from the supplier whether this is class 3. How can you assure me this is class 3? What kind of certificate you have? And the class 3 and class 4 classification is based on a standard document, which is actually an Australian standard. It's called AS Australian Standards 3566. That's the reference code for the document. Yeah.
Okay.
So yeah, I hope that answer your question.
All right. Thank you so much. Okay, moving on. Right. Let's say the question is like this. Let's say I'm using my building as a fertilizer warehouse. Where would the unwashed area be?
Fertilizer warehouse. We have inspected quite a few of those, and so and in fact, just now I showed some photos that were from the fertilizer warehouses, right? Where, I mean, just let me explain fertilizer warehouse first. So fertilizer warehouse is, fertilizer itself is corrosive to metals. And if, let's say, you have it in the stockpile, normally big factories, they would have it in the stockpile and then package it, or make it into granules and then package it. And sometimes you get airborne by the gust of wind or whatnot, and you can't really see it, but you can actually feel it if you have been to a fertilizer factory. When you come out, you feel that your throat is dry and it's quite agitating. And the fertilizer gets airborne, then it will stick onto the surfaces, any surfaces, right? It's very dusty sometimes. So it will fall onto the underside of the roofing sheets, including the structures, what we call batten. And those are what we consider as the unwashed area. So of course you can ask this question and make sure that if, let's say, it is really a fertilizer factory, how can the system, or so-called the cladding system, be in place to shield the unwashed area from being exposed to all these corrosive substances. Yeah, and of course it requires some discussion and some so-called clever designing by the provider. Yeah.
Okay, got it. All right, I hope that answered your question posted by Clarence. Okay, moving on. We have one question from Mr. Ahmad Suhaib. What's the largest size of one piece of aluminium cladding can go?
Well, largest size of one piece of aluminium. Sorry, Ahmad, I have to disappoint you, because I think I mean, I have not heard of any quantified largest piece of aluminum cladding it can go. But I do know that there is a concern on aluminum cladding. So when we say aluminum cladding, it means that there's no steel component in it. It's just pure aluminum. When it is such a case, right, then you have a heat expansion and contraction, right? And when that happens, you cannot go really long length. That's all I understand it from the heat expansion and compression. And with that, it comes, if let's say you have those fasteners, fasten, on the roof, then there's a risk of, that fastener going loose. So I have seen some companies doing some, trials to make it work, but I have not heard of, whether it's a good result or bad result. So, yeah.
Okay. All right. I hope that answered your question.
Yeah.
Yep. You can continue.
Yeah, I don't think that answers the question, but yeah, I give some perspective to it. But yeah, definitely you can ask those aluminum cladding supplier if they if there's a specific case. Most often they would want to comment on specific design, like warehouses. Yeah.
Okay. All right. Okay. We'll take one more last questions before we end the session. Okay, we have one more question, which is, will post-painting the copper lining conductor tape be able to isolate the galvanic reaction with the steel cladding?
Yeah, I never thought of this before. Post-painting, yeah, actually we have seen such thing being employed before, meaning people use copper tape and then they just paint over it. I would say yes, it would work to isolate the galvanic reaction, but to what extent that is still unclear, because we have not really observed that extensively. But my answer to it is yes, it will actually influence so-called isolate the galvanic reaction in certain level, because you have an added barrier protection. So my only question with that is that if let's say that can be done, can be painted over, why not just purchase a lightning conductor that has the insulation in place in the first place, like what I showed earlier, right? I mean, it reduces the on-site messiness or even additional work, right? So again, it comes down to the crucial questions that we need to pose when we are doing the designing stage, so that everyone is on the same page, be it architects with engineers in the lightning conductor case, and the designing. So yeah, I think conversation needs to happen at the early stage.
Yep. So I guess designing stage is where the crucial part is, when everything should be laid down and so that everything is clear and everything, so that later on there's no add-on, and then hence costs you even more after that.
Yeah.
Yep.
You're right.
All right. I guess that's all the questions we have for today. All right. Before we end this webinar session, Mr. Rocky, can you give us a number one key takeaway for our audience in line with today's topic?
Of course, today's topic was about the crucial questions to ask, right, for metal cladding, even the accessories for large warehouses. So I think the one key takeaway that I would like to raise is that whatever design for warehouses that you do, I think it's good to seek second or third opinions, and especially those experts that you consider them expert. And I think we are always open to conversations, and to make recommendations whether it's we can do it this way or that way. So take those informations that you have heard from me today and start posting questions to during the design stage to challenge the status quo, and to make sure that you initiate with the questions, but you hope to get a better solution in the end. So that in a way, I believe would be improving the design of large warehouses. Sorry,
okay.
It's not really a one-liner, but yeah.
Thank you so much for so ladies and gentlemen, please remember to ask more when you are in your designing stage, so that everything is covered. The more you ask, the more that things that you will be able to cover, so that you won't miss out anything on your end when you're designing your warehouse. All right, with that, I would like to take this opportunity to say a big thank you to our speaker today, Mr. Rocky, for sharing this session. As a last note to our audience, congratulations on successfully staying until the end of the ARCHIDEX Fast Forward webinar series. Are you also looking for the latest materials and also solutions for your architecture and building project needs? We are inviting you to experience Asia's leading architectural business event digital platform. So please register yourself for an exclusive access to ARCHIDEX Online today at the link in the comment section. And finally, do stay tuned for our next webinar session. Till then, stay safe and take care. Bye-bye. Thank you, Rocky. See ya.
Bye.